So we said yesterday that we can provide an electricity or electric current by using two spheres. One sphere is positively charged, the other one is negatively charged. And we said that positively charged sphere will have a higher electric potential. Negatively charged sphere will have a lower electric potential. And because there's a potential difference between these two spheres, when these two spheres are connected by a conducting wire, conductor, what does conductor mean? Means yesterday I also explained that. So you are going to observe an electric current from positive sphere to negative sphere. Yani, to set up an electric current in a conductor, there must be an electric potential difference between the ends of the conductor. Positive sphere makes this end high electric potential. Negative sphere makes this end low electric potential. An electric current starts from high electric potential to low electric potential, or from positive to negative. But we cannot always carry a sphere, charged sphere with us when we are going somewhere. Instead of using two charged spheres, more practical devices are provided or imported, which are called batteries. So these batteries are producing the potential difference between the ends of the conductor, because each battery, if you look at them very carefully, has a positive terminal and a negative terminal. A positive terminal and a negative terminal. Red is positive terminal, black is negative terminal. Positive terminal, negative terminal. So when you connect a device or a conductor, just a conductor, between those negative and positive terminals, you are going to observe an electric current starting from positive terminal of the battery to the negative terminal of the battery. So these devices, which provides electrical energy to a circuit, is named in physics as source of electromotive force. Any device which produces an electric energy to a circuit, to another device, so is called source of electromotive force. So batteries are one type of electromotive force, source of electromotive force, or represented by EMF source, EMF source. Symbol of EMF is epsilon. This is epsilon. So when you look at on the surface of a battery, you will see that what is the EMF value of a battery. For example, the first one is a cell phone battery. Its EMF value is 3.7 volt. Yani epsilon is 3.7 volt. Second battery, when you look at on the surface, you will see that written 6 volt. EMF value, epsilon of this battery is 6 volt. Third group is, when you look at the surface, you will see 1.2 volt. EMF value of these batteries are 1.2 volt. What does this EMF value mean? This EMF value means one terminal of the battery is greater in electric potential than the other terminal. Yeah, and a positive terminal of the battery will be at a higher electric potential than the negative terminal of the battery by that number. For example, this diagram tells you that this battery has an EMF value 1.5 volt. It tells you that positive terminal of this battery will have an electric potential greater than negative terminal by 1.5 volt. So this is a DC EMF source, and this battery is symbol in an electric circuit is positive terminal is drawn a little longer because high electric potential. Negative terminal is drawn a little shorter, which is the smaller electric potential. So this symbol is symbol of a DC EMF source, or symbol of a battery in an electric circuit. What does DC mean? Now first, let's talk about this. DC means direct current. Direct current. I'm going to talk about them in chapter 6 again, but direct current means when a battery starts giving electric current to a device, so its value never decreases, never increases. It has a constant value. Direct current means constant current. Constant current. It does not increase. It does not decrease by time. This current is called direct current. So every battery provides your device a direct current, yani DC EMF source they are. So what does the circuit mean? Now I will explain what the circuit mean. Circuit is, if you want to make a device on, for example, if you want a lamp to give light, so you should first set up an electric circuit. An electric circuit consists of three basic elements. One of them is there must be a device which needs electrical energy, such as a lamp. Lamp is a device which uses electrical energy, which needs an electrical energy to give light. Second one is you need a source of electromotive force. Yani a device must provide electrical energy to this lamp. This can be a battery, which is called an EMF source. Third one is a switch. There must be a switch to control the circuit. You can make this switch on, off to control the circuit. Yani you can make light on or you can make light off by using the switch. When you connect these three devices by conducting wires, you are setting up an electric circuit. Now I am going to set an electric circuit in here. So I have a lamp, I have a EMF source, a battery, I have a switch. So then I'm going to connect them by using a conducting wire. So I will connect one end of the battery to the lamp, other end of the battery to the switch, and other end of the switch to the lamp. So this combination, this connection is known as a simple electric circuit. When you make this 0 to 1, this lamp will start giving light, electric circuit. So, but in an electric circuit, you cannot always draw a battery, you cannot always draw a lamp, you cannot always draw a switch. Instead of you use some diagrams, which is called schematic diagram of a simple electric circuit. What does schematic diagram mean? So lamp has a symbol like this. This is a symbol of a lamp, which is represented by R. Battery is a DC battery, so DC battery symbol is this. If it is EMF value is 1.5 volt, you are going to represent here is equal to 1.5 volt. Third one is a switch. This is the symbol of a switch. So then we are going to connect these three devices by wires. So then you are going to set up a simple electric circuit. Now instead of drawing this, generally we draw in physics studies that diagram, schematic diagram for simple electric circuit. When you switch on the circuit, and when you make the switch on like this, as soon as you make switch on, electric current will start from positive terminal of the battery, pass through the lamp, pass through the switch to the negative terminal of the battery, and this lamp will start giving light. This is what an electric circuit is. What if your lamp needs 3 volt, but you have a battery which is 1.5 volt? Every device needs a sufficient electric potential to operate. Yani, if a lamp needs 3 volt electric potential to operate, 1.5 volt battery is not enough to make it on. Or it makes the light on, but light does not give enough enough light. If it is like this, the case is like this, we are going to use more than one EMF source. If a single EMF source, if a single battery is not sufficient enough to operate, is not sufficient to operate a device, for example, a lamp, more than one EMF source, more than one battery may be connected to that device. So now I'm going to talk about how to connect EMF sources to a device. There are two types of connection of the EMF sources. There are two types of connection of the batteries. First connection is known as connection in series, connection 1. So how we connect two batteries in series? If batteries provide electric currents in the same direction, this connection is known as series connection. Now there are two batteries. First battery between A and B, connected between A and B. Second battery is connected between B and C. Now let's look at the direction of the electric current. We learned that electric current starts from positive, always leaves from positive. So first battery's electric current is to the left. Look at second battery. Its electric current also starts from positive, leaves from positive. It is left as well. Look at their directions. First battery's electric current is to the left. Second battery's electric current is also to the left. So their directions are the same. This connection is known as connection in series. In this case, you are going to add EMF values of each battery to calculate the net EMF. So net EMF in this case is going to be EMF of the first battery plus EMF of the second battery, yani E1 plus E2 will be net EMF. If you add like these two EMF sources, net EMF value will increase like this. For example, there are two batteries. One of them is 1.5 volt. The other one is also 1.5 volt. Look at their direction of the electric current. First one is say that this, second one is that. So first one gives an electric current from positive terminal to the left. Second one is also to the left. So their electric currents are the same. So in this case, you are going to add their EMF values. 1.5 volt is the first one's EMF value. 1.25 volt is the second one's EMF value. 1.5 plus 1.5, so 3 volt is the net EMF value of these two batteries. So when you look at many devices, for example, remote control devices you have in your classroom, you are going to see that there are two batteries. Why? Why did you use two batteries? Why do they use two EMF source? Because one EMF source, 1.5 volt, is not enough to operate this remote control device. That's why they put two batteries in series, and so net EMF becomes 1.5 plus 1.5, which is 3 volt. So 3 volt is enough to make this remote control to run properly. In series connection, we are going to connect positive terminal of the one battery to the negative terminal of the other battery. Be careful about this. Positive terminal of the one battery is connected to the negative terminal of the other battery. Positive terminal of the first one battery is connected to negative terminal of the other battery. So this is a combination in series. Okay, but there is one more series combination, but this time, this connection type is a bit different. Connection 2. If batteries provide electric currents in opposite direction, like this E1 and E2. Now look at the electric current of E1. Electric current leaves from positive terminal, so it goes to the left. But for the second one, electric current leaves from the positive terminal, it goes to the right. So electric currents are opposite in direction. If electric currents provided by the batteries are opposite in direction, so in this case, you should subtract EMF values. So net EMF value is going to be E1 minus E2. Yani net EMF value decreases in this combination. This combination is not used in our life so many times, but when we are studying chapter 6, I'm going to talk about this. This combination, you should know about this for understanding one of the title in chapter 6, section 2, which is known back EMF. So if electric currents are opposite in direction for two EMF sources, to get net EMF, you have to subtract EMF source 1 and EMF source 2. Then net EMF value will decrease. So this connection 2 has no practical use in our life. Mostly we use the first connection because sometimes we need a greater EMF value. So for that greater EMF value, you are going to connect them in a way that so the electric currents will be in the same direction and the EMF values will be added E1 plus E2 plus E3 and so on. But look at their ends. Negative end of the first battery is connected to negative. If negative connected to negative, you should subtract them. Or positive connected to positive, you should subtract them. But look at the connection 1. If positive terminal of one battery is connected to negative terminal of another battery, so in this case, you should add EMF values. So net EMF value will be E1 plus E2. This is how we are using them in our life for many devices, such as the remote control devices. All right, now I will continue with another combination type, connection in parallel. Connection of the batteries in parallel. In this case, you are going to connect two batteries or EMF source so that their poles meet one another. So same poles of these batteries are connected. Yani positive terminal of the one battery is connected to the positive terminal of the other battery. Negative terminal of the one battery is connected to negative terminal of the other battery. So between these two ends, you are going to connect any device. So this combination type is known as connection in parallel. In connection in parallel, there is no change in EMF values. EMF value of the first battery is E. EMF value of the second battery is E. Net EMF between these wires again E. There is no increase, there is no decrease. So for example, look at this one. First battery has an EMF value 3 volts. Second battery has an EMF value 3 volts. The net EMF of this circuit is going to be 3 volts as well. There will be no increase, no decrease. Yani in parallel connection, you don't make a change in EMF value. But why to connect batteries in parallel? Now I will shortly explain that. So this is a single battery connected to a device. So if this device K, it's a lamp, say it is a lamp, if needs 1 ampere current, all this 1 ampere current must be provided by single battery. Yani from positive terminal of this battery, 1 ampere current must leave. But if we use two EMF sources in parallel, two batteries in parallel, so this lamp needs 1 ampere current, but each battery this time provides 0.5 ampere current. Yani 0.5 comes from first battery, 0.5 comes from the second battery. Some of them, 0.5 plus 0.5 becomes 1 ampere. So in this case, each battery provides less electric current. Why? What happens if a battery provides less electric current? So lifetime of a battery becomes longer. So if you want batteries' lifetime to be longer, better to connect batteries in parallel. There is no other practical use for connecting the batteries in parallel.
So E net will be 0, it will be same here?
Yes, same EMF. There is no increase in the EMF value, no decrease in EMF value. Only when you connect more than one batteries in parallel, electric current provided each battery will decrease because they will share the total electric current. If one battery exists, all electric current is provided by one. If two EMF value, two batteries exist, all electric current is divided by 2. If 3 battery exists, divided by 3, and so on. So they start giving less electric current. So that's why their lifetime becomes longer.